Good morning. So we are working on Unit 5, which is all about congruent figures. So our essential question for this, everybody, is how can we prove the angles of a triangle equal to 180 degrees? So we're going to go over that proof. So it is given that AC is parallel to BD. And we need to prove that the measure of angle 1 plus angle 2 plus angle 3 equals 180 degrees. Okay. And we're going to do our diagram. So 4, 2, 5, 1, and 3. And then this is A, B, D, arrows, and C. Okay. So we're going to go ahead and do a proof for that. So we are going to do a proof. So we're going to have our statements. Remember, these are your notes, so you can write an S if you want to, and reasons. Okay, so our first one, of course, we're going to write our given. So AC is parallel to BD. And that's because that's our given, so that's our first one, our given right here. And then we have that angle 1. So if we look at it, everybody, angle 4 plus angle 2 plus angle 5 is going to equal 180 degrees. They form a straight line. Okay, so the reason is the definition of a straight line. Okay, and then we also have that angle 4 and angle 1 are congruent to each other. So if you see, they're in between these two, this parallel line and the parallel side. And they're on opposite sides of that transversal AB. So angle 4 is congruent to angle 1 because their angle relationship is alternate interior. So they're on opposite sides inside. So it's our alternate interior angle theorem. Okay, and then we also have that angle, so angle 5 and angle 3 are also alternate interior angles as they are on opposite sides of BC, the side BC, and they are in between the two parallel line BD and the side AC. So angle 5 is congruent to angle 3, and they are alternate interior angles. And so now we're ready for our given. So angle 1 plus okay, so we're substituting in for angle 4. Angle 1, because angle 1 is congruent to angle 4, and we're substituting for angle 3. We're substituting in angle 5, because they are congruent. And so we're using our substitution property of equality. Okay, let's go over a couple examples. Draw triangles. Okay, not to scale, by the way, everybody. So 63, 85, and x. We're going to set them equals, so x plus 85 we combine like terms, and then we're going to subtract 180 minus 948 to get 32 degrees. All the angles are less than 90, so this is an acute triangle. All the sides are different lengths, so it's an acute scaling triangle.
Miriam Perez, Julian Griffith, Leland Will Danner, Marcelius McKenzie, please come to the bookstore. Miriam Perez, Julian Griffin, Leland Will Danner, and Marcelius McKenzie, please come to the bookstore.
Okay, now that the announcements are done, let's go back to this. Okay, so this one. Okay, so this is a right triangle, and this is 3x plus 5. Okay, so you can do this. So 90 plus 2x plus 3x plus 5 is equal to 180. Okay, we're going to combine like terms, so we're going to add combine the numbers, combine the x's. So we're going to get 5x plus 95 is equal to 180. Subtract each side from 95. Okay, and we get 85. 85 divided by 5 is 17. If we had to find the angles, we would substitute in 2 times 17 is equal to 34. And then what we know about the two, this is because this is a right triangle. Let's do it all together. Okay, so 3 times 17 plus 5 is 56. And we could check it. So 34 plus 56 is equal to 90. So that would be our check. Okay, so that would be if we had to find the angles for that one. And then we have for this one, and this is 3x plus 20, okay? And what we know about isosceles triangles, so the base angles are congruent because it's an isosceles triangle. So these base angles are congruent, so we're going to do 4x plus 3x plus 20 plus 3x plus 20. You could also do 4x plus 2 times 3x plus 20. It's totally up to you. So we're going to combine like terms. So we get 10x plus 40x is equal to 180. Subtract 180 minus 40. 140 divided by 10 is 14. Okay, everybody. Okay, so we're also working with congruent figures. So for congruent figures, all right, so this is congruent figures. then what does it mean for all figures to be congruent? So all the sides are congruent, and we can move it by rigid motion. Okay, so an example would be this one that we did. So this would be a reflection. Okay, so we reflected it. So we're going to list all the congruent angles and sides. Okay, so we're going to go ahead and do this, everybody. So we got this. So we have side, so I'm going to name this L, M, O, and P, R, Q. Okay, so for the angles, we have that angle L is congruent to angle P, and angle M is congruent to angle R, and angle O is congruent to angle Q. Okay, and then for the sides, we have that angle LM is congruent to PR. And everybody, when you're doing this, look at this is the first and second angle. So look for that for the congruent sides. And so then between the second and third angles, we have MO. So MO is congruent to RQ. Okay, and then we also have that side low, which is between the third and the first one, is congruent to PQ. Okay, so our triangle congruent statement. So triangle LMO, so we're going LMO, is congruent to triangle PRQ. So when you're doing this, you just need to make sure you're going in the same direction. Okay. And then we also have okay, so we have this one. Okay, so for this one, you think about it like they're sharing a side. So they're sharing this side AC. Okay, you can also think of it as like they're kissing. So they're sharing that side AC. Okay, so we're going to do our congruent angles again.